Welcome to The Explainer. Today, we're deconstructing one of humanity's most terrifying creations. We're going to build a science-based model of what happens when a nuclear weapon is used, tracking the consequences from the very first microsecond, out to decades, and across the entire globe.
All right, here's how we're going to do this. We'll start with the raw power of that first second. Then watch as a whole city is literally wiped off the map. After that, we'll get into the invisible killer, the radiation. And finally, we'll zoom all the way out to see how a nuclear war could plunge the entire planet into shadow and what all of this means for our future.
To really wrap our heads around the scale of this, we have to start right at the hypocenter, in those first unbelievable moments of the explosion. Everything that follows, it all begins right here.
That is an almost incomprehensible amount of heat. I mean, for a split second, it's way hotter than the surface of the sun. This heat comes from a fireball that expands at an insane speed, and it shoots out this blinding flash of thermal radiation. And here's the kicker. Because that radiation travels at the speed of light, it burns everything in its path before the sound or even the shock wave gets there.
Now, this is where you can really see those cascading effects. The blast wave, yeah, it's powerful enough to flatten most buildings within, say, 1.7 kilometers. But look at the thermal radiation, that heat flash. It travels much further, causing third-degree burns at 2.5 kilometers. That means you could be standing in the building that actually survives the blast, only to have been incinerated by the light that arrived just moments before.
And this is the immediate human cost. Survivors from Hiroshima, like Kiko Ogura, who was just a little girl, described a world that was just instantly on fire. They saw people whose skin had been burned away by nothing more than the light from that initial flash. It's a kind of trauma that just lasts forever.
So let's zoom out a little and see how that initial flash builds, moving from harming individuals to the complete and utter obliteration of an entire city.
You have to remember, on the morning of August 6, 1945, Hiroshima wasn't just a target on a map. It was a living, breathing city. You had about 350,000 people there, going about their day in what was a really important transportation and military hub. This contrast just says it all. In minutes, the physical city was just gone. 90% of its buildings wiped out. But look at the hospitals. That's what's so critical. Out of 16 major hospitals, only 2 were left standing. The very systems you would need to help people in a disaster were some of the first things to be destroyed.
And if you thought the blast was the end of it, well, it wasn't. The crazy heat, combined with ruptured gas lines and thousands of wooden buildings, kicked off a secondary and honestly even more terrifying event, a firestorm. Now, this isn't just a really big fire. It's basically a weather event. It creates its own gale force winds that suck oxygen and everything else into its center, creating this self-sustaining inferno that just eats whatever is left of the city. For anyone who's somehow survived the heat, the blast, and the fire, the danger was far from over. An invisible, insidious threat had just started its deadly work. 2.4 million. Just let that number sink in for a second. That's the estimated number of cancer deaths caused not by a nuclear war, but just from the atmospheric testing that was done between 1945 and 1980. This really shows you that radiation isn't some localized problem. It's a silent poison that spreads across the whole planet and across generations. And this timeline just shows the cruel, drawn-out nature of that poison. In the first days and weeks, you have acute radiation sickness. Then, years later, leukemia cases spike. Then, decades later, other cancers start showing up. And of course, for the rest of their lives, survivors are dealing with severe psychological trauma. The bomb goes off in a second, but its effects, they never really stop. Think about what that really means. A 50% increased risk of cancer for the rest of your life. It's this permanent shadow hanging over a survivor's health. And that risk is even higher for people who were exposed as kids. It's basically a life sentence of medical uncertainty, all from just one moment of exposure. Okay, so now we're going to zoom out, way, way out, to the largest possible scale. What would a nuclear conflict, even a so-called limited one, mean for the entire planet? The whole concept is chillingly simple. Those massive firestorms we just talked about, imagine those happening in dozens or even hundreds of cities all at once. All of that soot and smoke gets blasted up into the stratosphere, and this layer of black carbon spreads around the globe, blocking sunlight and plunging the Earth into a sudden man-made winter. And the consequences are almost beyond imagination. A 2021 study in the journal Nature Food modeled what would happen. The result? A 90% drop in global caloric production. This isn't just a food shortage. This is the total collapse of global agriculture. The study concluded it could lead to a worldwide famine, killing over 5 billion people. That's more than half of us. So this reveals this terrifying feedback loop. Our current climate crisis creates instability and fights over resources, which, you guessed it, increases the risk of war. A nuclear war would then trigger a nuclear winter, which is a sudden, extreme form of climate change, which in turn makes any kind of global recovery almost impossible. Each crisis just feeds the other. And that's exactly why experts now call them the twin existential threats. These aren't separate issues we can solve one at a time. They're deeply connected, and each one makes the other more likely and a whole lot more dangerous.
Okay, let's pull all these cascading effects together and really try to understand what this 80-year-old technology means for us right now in our super interconnected world.
$156,000. That's how much the world's nuclear powers spend every single minute maintaining their arsenals. And this isn't just about funding a threat. It's a massive diversion of money and resources away from solving the very global problems like climate change that make conflict more likely in the first place. So, what's the big takeaway here? I think the key is to see this not as a single event, but as a cascade. It's a chain reaction of destruction that starts with physics, becomes biology, and ends as climatology. It's a single human decision that has the power to unravel the entire planetary system. So from the physics of the blast to the climatology of a nuclear winter, what we're really seeing is a single, interconnected web of destruction. And understanding that, that's the first step. The challenge that's left for all of us is how we navigate a future where our most dangerous creations are so deeply and so dangerously intertwined.